Okay, I had a little setup from John. I'm not going to cover BNSF again and show the map and how many miles and locomotives and all that stuff, but our boss is Warren Buffett, so I thought I'd quote him again. And I thought Brad Crawford, I left this one in. I quoted this one last year, but I thought Brad Crawford would appreciate it, right? It's a tree. And that's the first one. Someone's sitting in the shade today because someone planted a tree a long time ago. And you think about your career and what you've done. You've had a lot of mentors and people come along the way, and just think of the improvements that have been made. And we've got it really good. I mean, I even think about in my career, just running around all the time and derailment to derailment. And I think we've really improved, and it's because someone planted a tree a long time ago. And the other thing is if it's just not necessary to do extraordinary things to get extraordinary results. You think about that one, and it's the low fruit has been picked. It's harder and harder to make improvements. Think about that. So the nuggets, they're still out there, and there's still a lot of improvements to be made, but it's not easy. Well, last one there is risk comes from not knowing what you are doing. And that's what we're doing here, right? We're trying to reduce risk. And, at times you have to accept some risk, of course, to move forward, but you want to minimize that and understand what you're going to do. And then I don't know if Warren Buffett, I paraphrase this last one, because I think some other people have made that comment too. But, you think about this conference here, and there's a lot of smart people in the room. You start looking around, I see a lot of industry experts, and and that's why we're here. We're surrounding ourselves. You can't do this stuff on Zoom, all the sidebar conversations and things like that. So it's really great we're here. I'm just comment here. I mean, really what we're doing up here with standards and some of the things that John talked about, we're just reducing track impacts, right? When impacts happen out online, bad things happen. So a lot of our design and considerations are really because we're trying to reduce impacts. For 22, we've been looking at tie pads for quite a while. I can't remember exactly when we started, maybe 2015 or so. And this year we're kind of moving into a large scale test. We've got 6 miles going out on the Kansas area. We've got some crossovers we're putting in California. We got a wood tie crossover going in Kansas. We've got some transitions that we're doing, road crossing transitions, and I'll get into some of these a little bit later. We're continuing with our ballast mat and putting concrete ties on bridges, and then of course our diamond program, and I think we've pretty well settled on that one. And of course we need that population to reduce variability. You do these tests and sometimes things don't go right, or you get a result, and the more you have out there, the better your result's going to be. And then of course the big one, you gotta answer, right? Is it going to pay for itself? That's the bottom line question. Is it going to make sense? Is it going to pay for itself? I don't cover this one a lot. I think I've shown this one in the past too. With under tie pads, you're really increasing your bearing area. That's kind of it in a nutshell. And ultimately, we're trying to reduce, the ballast breakdown and the bad things that happen after that. I was out with Rusty Crawley here with Vossel. There's Rusty. We went out, was that 2 weeks ago? We went up on Crawford Hill, and ironically, it's the same curve that John Check mentioned in his talk here a little bit ago. But the very same area where we tend to go to these areas, right? That this is where we have our biggest problems, right? So you want to test everything, and if it doesn't work up there, then it doesn't work. But that's not necessarily correct. But anyway, we walked that, and we're always looking at, you always pick up a lot of things because things obviously happen very fast up there. And the other site is Cajon Pass out in California, dropping down into the LA basin. Things happen fast, and you got to keep up with things. So usually if things pop up there, we like to jump on them to make sure that, we're ahead of the game. So if it happens somewhere else, we're not unprepared. But I think also we need to look to other sites too that have been successful. There's a picture there on the left, and that's, as far as I can tell, Adam Bankston is here. He's our tie expert, puts together our program. But as far as I know, these are the oldest ties still in track. And they actually date to 1970. I think they were part of an AREA test, and they're still out there. So you start thinking about that, that's like 52 years ago, and they're still out there. So maybe these things work in other areas that we should be putting them in, tangents. The other site there is on the Emporia sub in the middle, and that was part of the, I think it was part of the line change there when they put the lake in there in the middle of Kansas near El Dorado. So the magic question is, how long will they last? And, some of the testing here we've done are with, I'm going to get this wrong, I'm going to say TTCI, but it's MXV. But here we took some of our ties that we thought had failed, they put them in track, and they lasted another, 600 million gross ton or something like that. So some of the ties that even look ugly to us, I mean, they seem to be lasting really well. Just hit on this one a little bit too. I know John mentioned a lot of this. We're trying to be more technology driven and to make better decisions. We're trying to eliminate our service interruptions, like John said. So to do that, we got to understand why. I'm going to mention Charity Duran. I think this data team is probably one of the best decisions ever made by BNSF. I can remember when I first started, we were putting together the RIS program, the Roadway Information System, and we didn't even know what kind of rail we had out there. But starting in the late, I forget what year, 1989, we were out there just with a clipboard, looking at the stamps on the rail, trying to inventory 2,000-3,000 miles of track out on the Nebraska division. So I'm really excited about that, because I think that's going to be huge as far as evaluating, a lot of the things that we're trying out. We do a lot of tests, and in the past it's been, we think it's better, but this really helps us. So I'm really excited that Charity's in that position, and I think it's great. The other thing with tie pads I'm going to mention is refinement and analysis and production and considerations and cost. Anytime you're introducing something new, there's a lot of products out there, a lot of things to test, a lot of ways to test it. And this was one actually that just got started. I was approached by Dow about tie plugging material, and I said, hey, can you put something on the bottom of a tie that would give us a pad and behave in a certain way? And lo and behold, they came up with something now. And I don't know if there's any Amtrak people here, but I think they've ordered, they jumped us a little bit, because they got a test strip out there, and I think it's performed well. They've skipped a couple tamping cycles, and I think they've ordered 40,000 more ties. So they're forging ahead of us. So we don't like to be behind, but that's just something we're looking at, or at least one design. As far as installing, you always learn a lot of things, and that's why you never want to do like a large scale installation, because you learn things as you go. So we've learned some things during these installations. You can see on the, I guess on the left there, when you think your ballast mat is laid down on your bridge and you go out and inspect it, and the cats kind of tore it up when they put the ballast on. So things happen out there, and there's a lot of ways we can improve, and sometimes it skews your tests and throws things off. The middle pictures there is some of the first spray-on type pads that we did, and you can see some of the overrun, and that created some issues in the field as far as ties sticking together and rolling and things like that. So there's some improvements we can do there. Of course, you add a pad to a tie, and the clip, our dunnage, everything gets really close. Our TLM can't clam them up to set them in the machine. So there's those kind of considerations. On the right there is a padded wood tie turnout we did in Illinois, and the pads come off if people aren't careful. And so there's a lot of things you learn as you go along. We've had a lot of help here from Getzner and others as far as evaluating, what kind of pad should we use? We like to keep things simple because the more complicated you make things, the more you screw it up usually. So we're trying to keep things simple as far as modulus transitions and staying with a limited number of pads. Another improvement here, and this is out in I think Days, Arizona. We put this curve in and quite a few years ago already, but the pads have a way of holding that in place. And I called the roadmaster the other day and I said, "How's your curve holding up?" He said, "What curve?" And this was a curve he was calling about all the time. "Hey, this thing's moving all over the right of way." And so we've seen some success there with locking that curve in place with pads. We're also looking at pads with IJs. We typically put wood tie panels in, so we're looking at padded ties to control the deflection at IJs. That's something we've done some testing, and we still are. We haven't quite adopted that one yet. We adopted this one probably in 2015 as far as putting pads on bridges, and we've had success with that. That's out in New Mexico there by Fort Sumner, Pecos River. But anyway, our old standard was you'd come in concrete, right? And then you'd go wood ties across the bridge. And so we went with ballast mat and wood, concrete ties across the bridge, just to keep that homogeneous tie type for future maintenance. I don't know if Kelly's still here. I got Kelly working on some of our road crossing initiatives as far as that's another place we see with our geometry cars. We get dips and issues going into road crossings. Diamonds, I think we've kind of settled where we're going to go on this one. We've tried under casting pads and they just haven't worked for us. It's been too much vibration. So we've settled on this. And here I said TTCI. I said I wasn't going to say it, but TTCI helped us with that one. And I think we've settled on that as far as our design. This was another one, and Ricardo's still here. Maybe he's gone, but we're going to be looking at this too as far as transitions going into road crossings. And then, something we've been looking at too, and this is one I walked with Rusty the other day up in Torrington, Wyoming, coming up with an interspersed tie that works in track where you can convert to concrete over time. So it looked pretty good. There was one spot there, and you hate to taint a whole test on one spot, but sometimes that happens. So we're still open to that one. As far as this one, I think I'll turn it over to Brett. I kind of sped through mine and I'll let Brett go and turn it over to you.
Okay, is my mic? Yeah, my mic is, no, my mic is just. Okay, can you hear me in the back? Perfect. So we presented the beginnings of the University of Illinois BNSF under tie pad research project at last year's virtual symposium. For this symposium, we have a couple of updates as well as some new research that we've been undertaking in the past year. The motivation and objective is the same as it was last year. We are looking at the effects of under tie pads on substructure stresses and the overall performance of the track. And we want to figure out if the under tie pads save enough money in asset service life and in maintenance costs that they are worth the outlay of that BNSF would have to spend at the beginning of the project. So the first thing we did is we went into the lab to look at the magnitude of the substructure bearing pressures under various cross tie types and under tie pad types to inform the field work that we are doing in the open track. We completed this last year and we presented it at this conference last year. Then we went to the open track out in Arizona and we were looking at the substructure pressures, the subballast pressures resulting from either a section with under tie pads or a section without under tie pads. We are also looking at turnouts. BNSF has a bunch of wood tie turnouts on their network, and they've been interested in adding under tie pads to those turnouts. So we've been looking at that. And finally, as Eric mentioned about the Emporia sub, there's the 6-mile section on the Emporia sub, which has bridges, curves, and road crossings. So we've been starting to investigate that. And finally, we will be heading back into the lab to look at some more mechanical characteristics, contact pressure distribution, and the fatigue resistance of different under tie pads. So that will be the upcoming lab work we will be doing over the next year. We will be looking at, first and foremost, the mechanical characteristics and the pressure distributions, which will be largely an expansion of the work that Jacob Branson completed here at Railtech in 2019 and 2020. In addition, we will be looking at fatigue resistance, in particular, the mechanical resistance to repeated loading and also the breakdown of under tie pads over time. There isn't a lot of published third-party research on the life cycle and the amount of time that under tie pads last. And so we're hoping that we can get an idea as to how long under tie pads last with the research that we've been doing here. So the next thrust of our research is the turnout improvement study. And what we're looking at here is installing under tie pads on BNSF's standard wood cross-tie turnouts. So currently we have three sets of turnouts, each with a control turnout, each with a padded turnout, 2 in Illinois and 1 set in Oklahoma. And we will be adding the set of turnouts in Kansas once they are put in place. We are looking at a variety of metrics, the vertical track deflection, which is the deflection at the point of frog, to look at the displacement of the frog casting. We're also looking at the frog casting acceleration to look at the wheel impacts. We are looking at the absolute and differential track settlement by level survey to look at compaction and consolidation of ballast, plus any potential issues with differential settlements. And finally, we'll be looking at the geometry car data to look at the rate of degradation of the geometry. So the padded turnout, the padded crossover, the padded turnout, we have a section of softer under tie pads in blue and stiffer under tie pads in the orangish reddish color. And the idea is, since the point of frog tends to be the stiffest point of a turnout, we want the softest pads there to basically create a uniform stiffness between open track, the turnout, and then the point of frog. And the control crossover has no pads, so it is basically any other crossover that you would find on the BNSF network. So we have some preliminary results from the turnout study, with the note that we are only at about 40 million gross tons for the 2 turnouts in Illinois. And we're hoping that we can run the study through at least about 100 million gross tons or so, which is what the UIC over in Europe recommends for an under tie pad study. But the padded turnouts between Illinois and also the 2 in Oklahoma, which are up a little higher in their tonnage, are showing a pretty consistent displacement between about 6/100ths to 10/100ths of an inch, whereas the control turnouts, the unpadded turnouts, are much more variable. And we have also been noticing that the frog casting displacements, they start quite high and then they decrease pretty rapidly till about 15 million gross tons, and then they seem to level off. So the one thing I will note is that we're only at 40 million gross tons. As we get more tonnage, we're hoping that we get a little bit more results, but it's a good start. Some other preliminary conclusions at 40 million gross tons. As I mentioned, we seem to have more consistent deflections with the padded turnouts. The padded and non-padded turnouts seem to show similar frog casting accelerations and also similar settlements, but we're only at 40 million gross tons. The geometry data change right now is quite minimal at the time and tonnage we have. And 2 other kind of side notes is the Illinois turnouts are on a shared Amtrak freight corridor, and the freight locomotives cause a greater deflection than the Amtrak locomotives, which makes sense because the freight locomotives are heavier. And we also have straight and diverging movements, and the frog deflections between the straight and diverging movements in the vertical direction seem to be about the same for each, all else equal. The second thrust of our research in the field is the open track bearing pressure study out in Arizona. So we have a section with 1 type of under tie pads a section with a second type of under tie pads, and then a section that has no under tie pads. And we are measuring the ballast pressures 4 inches below the top of subballast at each of these sections. So we have 3 pressure cells for each tie and 2 ties per section. So we can look at the pressures at the center, at the rail seat, and at the shoulder for each section, and then also compare between 2 different ties. So we should be getting similar pressures for both ties in the same section. And we have a load cell, a strain gauge load cell above the cross ties for each section. So the idea is that if you have identical loads for each of the 3 sections, and you have one section that has significantly less pressure than the other 2, then that section is probably outperforming the others. And we've been in for about 18 months here, and we're hoping to present the results soon, but we don't quite have them yet. So finally, as Eric mentioned, we have the Emporia section, and we have about 6 miles of track, some control track, some padded with one type of pads and some padded with another type of pads. And each of these sections has a road crossing, a bridge, and then the 2 padded sections have a curve. So that allows us to compare a number of different metrics across each of the sections. And so we can look at the absolute and differential settlement. We can look at some cross-tie performance metrics. We can look at some lateral resistance and curve metrics. And finally, we'll be looking at the geometry car data to look at geometric degradation and also potentially to find additional locations that are problematic and may be worth instrumenting more in the future. So here's a good wrap-up table for some of the future work we will be doing. I won't go through this too thoroughly in the interest of time and in the interest of that I've covered most of it. But a couple of other things are the ballast degradation through GPR or field work and sieving, and also some tie condition bending tie support tests. So I will hand it back to Eric, who will give a few wrap-up comments.
Okay, I think I got a green light. Thank you, Brett. Very exciting work going on here with our tie padding study, and I think we're getting enough territory or enough pads installed. I think we'll be able to make some good decisions going forward. That first stretch there actually was a 3-mile stretch, and now we're doing another 6 miles this fall. But I think we really need stretches like that to really be able to evaluate, how they do. And then to close up, I'd like to thank and give a shout out to Zach Dombrow. He's sitting over here. Zach is a big driver of this over COVID. There's some issues in my family. I wasn't able to get out as much during COVID due to sickness, and Zach really stepped in, and I just want to thank him for helping UIUC get out there and get all of this testing done. And Rob Bannister, he's not here. He retired here recently. And then Greg Freck, who is in Charity's team, be doing some of the data analysis. And then Kelly, who had to take off to the airport, and she's working on some of the road crossing initiatives. And then, of course, all the U of I folks here. I'd like to thank them. Just tremendous team, great ideas. MXV Rail, Vossloh, Gessner, Dow, Progress, and NordTrack. It's like, it is a collaboration to figure this stuff out, and I appreciate all the efforts that everyone's contributed. So with that, I guess we'll see what happens here, and hopefully be back a couple years and report, give some more report. So thank you for your time.
All right, great. One person I want to give a shout out to is Professor Jerry Rose as well, who was instrumental in the beginning development of the pressure study and giving us guidance on that. So thank you, Professor Rose. Any questions? Vince.
On the type of pads that are referenced, is the type different manufacturers or different durometers or different materials? What's the difference between the types? Okay, okay.
As you think about it, how many thicknesses can you have? You know, how many bedding moduluses can you have? You know, what is the best place? So, I mean, I think we can really show pretty quick if we can skip tamping cycles and start to show, hey, we can pay for these things relatively quick. I think that's an easy putt, right? But then to start dialing in, what do you do right before a road crossing or a bridge? You know, those are the really tough things to figure out.
If you're speaking to the turnout specifically, the turnout is the same manufacturer, 2 different stiffnesses.
The distribution, the pressure distribution is such so much lower when you use the under tie pad. Have you thought about modification of the center spacing, or are you just for now sticking with the standard spacing?
No, we're sticking really with the standard spacing till we understand that better, how it distributes the load to the subgrade, which I think is going to change over time. You know, it's not necessarily a static thing, and this is going to be a long-term study, of course, and hopefully we can make some decisions before that. But I do think that, you know, one of the primary things, and even when Rusty and I were out on track, anytime you saw concrete ties with mud and broken ballast, and you know, that's where you run into the problems. And if we can eliminate the ballast breakdown, I think they're really going to show that they're going to pay for themselves.
Any other questions?
All right, thank you.